Hello students, this is going to be section 11.4 and this is on the properties of logarithms, specifically the product and the quotient rule for logarithms. So before we go on, let's just recall that if I had something like, let's say it was 2 to the x power times 2 to the y power. So I'm multiplying two numbers with the same base. What can I do with the exponents? I can add the exponents, right? Kind of like 2 to the third times 2 squared. We said is 2 to the fifth, right? Because 2 to the third is 2 times 2 times 2, and 2 squared is 2 times 2. So altogether here I got 5 2's. That is, I'm multiplying 2 by itself 5 times. Okay, I'm going to just go ahead and present to you the product rule for logarithms, and then I'm going to prove it to you, and then I'm going to use it. It says if I have the log in any base, some base b, and if I'm taking the log of two numbers multiplied together, then I can add the logarithms of x and y. You want a proof? You want a proof? I'll show you a proof. You're writing this down? If you're not done writing this down, I'm going to show it to you on the next screen, so it's okay. Copy, and here we go. But it's here. Wait, it's going to magically appear. Bam! There it is. So this is the statement I want to prove here. I want to prove that the log of xy, log base b of x times y equals the log base b of x plus the log base b of y. So I'm going to start here to prove it. So a lot of times PF, that stands for proof. So if I have, let's say log base b of x, and let's just say it equals some number, we'll call it m. And same thing here, the log base b of y, well, I can take the log and it's going to be some number n. But if I rewrite my logarithms from what I learned before, then I'm saying b to the m power equals x, and in this case, on the right side here, b to the n power equals y. So if I am looking to take the log of x times y, the product of x times y, that is, then I could rewrite these x and y. X was b to the m, and sorry, I got my equal sign here in the wrong place. X was b to the m power, and y was b to the n power. And that is now going to be b to the m plus n power. Now I'm kind of saying, hey, b to what power equals b to the m plus n power? Well, that's going to be m plus n, right? Because again, b to what power equals b to the m plus n power? Well, that's going to be m plus n. Now I'm just going to back substitute with what I started with up here and go, well, the log of, m was log base b of x, and then I'm substituting n for log base b of y, and I have proven what I started out to do. And if you don't believe me, I started with this side of the equation, that's that side, and I've worked through some logical steps, and I got the right-hand side of the equation. You guys all owe me money now that I proved that. I'm just kidding. I'm kidding. So let's try some examples. Why not? It's Friday. It's not Friday. So let's do an example and see how to use this. What if I had something log base 6 of 54. Why not? And maybe I just feeling weird or lazy or whatever, and I realized that 6 is a factor of 54. And why 6? Because it's the base here, right? This is a... So I'm going to rewrite 54 as log base 6 of 6 times 9. Now, since I'm multiplying the two numbers in my log, I can add the two together. And is there anything I can do to simplify? Well, what's log base 6 of 6? 6 to what power equals 6? To the first power. So this whole thing could simplify to 1 plus log base 6 of 9. Yeah, fun, right? No, awful. The worst day of my life. Well, it'll get better. What if I had something like the log base 4 of, I don't know, 16x? Well, what could I do here? Yeah, so this is going to be the log of base 4, that's a 4 down there, of 16 plus the log base 4 of x. And what's log base 4 of 16? 4 to what power equals 16? Good. So this whole thing could reduce this way as well. I know, kind of weird, right? We take the log of 16, log base 4 of 16x, and it ends up to be, we started with a multiplication problem and it turns into an addition problem. It's pretty cool. Logarithms are pretty powerful. Let's do another example. What if I had something like log of base 3 of, I don't know, x cubed? Well, check this out here. So isn't x cubed like x times x times x? So what that pretty much means is I can add the log of x plus the log of x plus the log base 3 of x, which was 3 altogether log bases of x. I've actually just proved something that I call the power rule. And in fact, let's go ahead and define the power rule. So throw this one in your notes. Power rule. I mean, I guess I didn't prove it, but I got to it. It says that log base b of some number to some power r is going to be r times the log base b of that number x, which is exactly what I did here. Long story short, with the power rule, what it allows me to do is essentially it takes this exponent and allows me to multiply it in front. You see how I got that answer? Because again, we can kind of go that, hey, log base 3, or let's do it this way, 3 to what power equals x cubed? It doesn't work out that way. Forget I said that. That was a little confusing, but you know. Let's try a problem. Let's see if we can expand this log. So we go expand. These problems sounding familiar. Expand log, I don't know, 3x cubed y. Woo, it's crazy. Okay, before I pull out, if you're thinking, okay, let's use the power rule, before I pull out that cube, this cube, I need to separate my terms. Okay, I'm multiplying 3 numbers together. That means I can add the logs individually. And I forgot to mention, notice how I'm missing a base here. If I don't have a base, what base do we imply that our logarithms are? 10. Good job. Somebody remembered that. Nobody remembered that. Nobody said anything. I just made that up. So what I just did is I'm multiplying 3 numbers, so that means I get to add the logs together. Log of 3 isn't going to reduce, but does the log of x cubed reduce? Yeah, now that I got that cube by itself, that was a, I can't write a 3. That cube here gets to go out front by the power rule, so this will be 3 log x, and then lastly plus log y. I just want to show maybe another example using real numbers and how these work. It's kind of neat. Example, come on, dude. Okay, there it goes. My stylus wasn't working. I'm just going to solve this one a few different ways. Okay, log base 2 of 32. Do you know what the answer is? We've done this one before. Good. 5, yeah. But I want to show you a couple different ways of solving this. Okay. Method number 1, using the product rule. And let's say I just didn't recognize that 32 was 2 to the 5th power, but I did realize that this is the same as 16 times 2, which is 32. Well, that now says that I could take the log base 2 of 16 plus the log base 2 of 2, again because I'm multiplying 16 times 2, I can add the logs. And what's log base 2 of 16? 2 to what power equals 16? And what's log base 2 of 2? 2 to what power equals 2? Good. And there's another way I could have, again, I started with log base 32, and I got the answer 5 in this case without actually knowing that 2 to the 5th was 32. Or maybe another way, method number 2, I'm going to use the power rule this time, and it's kind of redundant, but what if I already knew that log base 2, that 32 was 2 to the 5th, so I'm just going to replace 32 here with 2 to the 5th. The power rule now says that I can take my power here and multiply it out front. So that's going to give me 5 log base 2 log base 2 of 2. And what's log base 2 of 2? 2 to what power equals 2? Again, I'm multiplying in this case 5. 5 times 1 is 5. So yet another way to use both the power rule and the product rule. Okay, 2 more rules I'm going to throw at you today. You want to know all these. And this is the quotient rule. And it's very similar. And the quotient, that's a Q, rule says that log base b of x divided by y is going to be log base b of x minus log base b of y. Notice the minus goes to the denominator. And actually, I'll give you a quick proof of that. My proof, and I'm just going to use the fact that that 1 over y is going to equal y to the negative 1, and then I'm going to use our product rule. So I'm saying that the log base b of x divided by y, I'm going to rewrite that as log base b of x times y to the negative 1 power, since if I divide by y, that's the same as multiplying by the inverse. And now I can use my product rule, so that's log base b of x plus log base b of y to the negative 1. And now using my power rule, I'll take the negative 1 power here and I'll put it up front. So that'd be negative 1, and that's just going to change that to subtraction. So there's a proof of it. And let's go back to our log. I'll show you again how we could use this looking at log base 2 of 32. Again, maybe in this case I didn't recognize that 32 was 2 to the 5th power, but for some reason I did recognize that 32 is the same thing as 64 divided by 2. Same thing, right? So that says now I can take the log, and I recognize that 64 was a power of 2. So that says this is the same as the log base 2 of 64 minus the log base 2 of 2. And log base 2 of 64, 2 to what power equals 64? 6 power, good. And log base 2 of 2 is 1, so this is 6 minus 1. This gets me 5, which again, looking at my original problem, I knew that 2 to the 5th power is 5. So yet another way of proving it. Let's try a crazy problem. Why not? It's Friday somewhere else besides here. All right, let's expand. Big problem here. Log base 3 of 9x to the 3rd over y squared. Yikes. Oh man, what am I getting myself into? Okay, step number 1 with the division. I'm going to break this up into just 2 logs, subtract my numerator, the log of my numerator from the log of my denominator. So let's do that first. Thrown out every bell and whistle on this one. So if you can do this one, you're going to be in good shape. And I just subtracted the 2. So on the numerator, on the 9x cubed, this first term here, this first log, I see that I'm still doing 9 times this number. So this is going to be log base 3 of 9 plus log base 3 of x cubed minus log base 3 of y squared. Last step, I can use the power rule, and I could also solve any log that I know. For instance, what's log base 3 of 9? 3 to what power equals 9? Nailed it, 2. And here, I can use the power rule to get the cube out, multiplying that. And then lastly, too, I can use the power rule to pull out that square. And this is about as simplified, or not simplified, unsimplified as we get. Sorry, there it is. One last property. Your book calls this a special property. I like to call these the identity properties. And then I wanted to try a couple more problems. The identity properties look a little funny, but let's start with the easier one. It says that log base b of b to the x power is x. And we already kind of did this. We kind of said that, hey, log base 2 of 2 to the 5th power is 5. But the other way of doing this around, and this is a little bit more confusing, but in the other direction, if I do b to the log base b of the number x, this is going to equal the number x. So let me try an example of the second one there. So let's evaluate 2 to the log base 2 of I don't know, what do you want, 32? That sounds good. So this property, number 2, says that this answer should just be what? Yeah, the number inside my log. This answer should be 32. So let's see if they're right. Well, what's log base 2 of 32? I'm just trying to simplify this expression right now. 2 to what power equals 32? Oh, that's 5, right? So I just completely simplified log base 2 of 32. How are you? And now I have 2 to the 5th power, which is 32. Point taken. I'm going to do 2 more problems, styles of problems. On one version, we expanded our logarithms. Let's simplify a logarithm. So we're going to use our rules backwards. So let's simplify log base 4 of x minus log base 4 of y squared. Okay, so I'm subtracting the two logs. Which property should I be using? My product or quotient rule? Good. Quotient rule. So this just says if I'm subtracting this from that, that's the same as dividing. Let's do one more. Let's simplify. 2 log, we'll just leave it as base 10, x plus 3 log y minus log of 20. Okay, so before I combine logs, I want to get rid of these multipliers here and reverse power rule these guys. Log x squared plus log y cubed minus log 20. Now if I'm adding the two, so I'm adding these two together, that means I get to multiply, and I'm subtracting this, that means I divide that. So this whole thing should end up being x squared over y cubed, times y cubed all over 20. And that's my log. Wah, 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 wah. One last one. So given that the log of 8, we're in base 10 right now, equals 0.903, and the log of 80 equals 1.0903, let's see if we could A, find the log of 640, and B, find the log of 10. You might already know what that is, but we'll get there in a second. Okay, so I'm just given this information, no calculators. So 8 times 80 is 640, right? So if I rewrite this as 8 times 80, that's going to allow me to use the product rule. That says I can add the two logs, which guess what? I've got these values from above. So if I add those together, I got 2.806, and that's the log of 640. I'm just going to check it on my calculator because I can. Yay, 2.806. Bam. Okay, how about the log of 10? And again, we are in base 10 here. But again, let's just use the fact that I have the log of 80 and the log of 8, and I know that 80 divided by 8 is going to give me 10. So that property, I'm using my quotient rule that says I can subtract my logarithms now. So this should be 1.093, that was given above, minus 0.903, that's going to equal 1. And that should make sense because log base 10 of 10 is 1, because 10 to the what power equals 1? Sorry, 10. 10 to what power equals 10? Yay, 1. You survived my lesson. Aren't you proud of yourself? Thanks, guys.